Thank you. I want to thank the ESPID board and the ESPID president for electing me and honoring me with this year's Birmalser Award. I joined ESPID since the early start of my career, many years ago, just after completion of my training, and since then I haven't missed but just one or two meetings. I served several times in the committees and in the board. During all this time, including 2 terms as ESPID secretary, all this time ESPID has been a scientific home to me, where I met great people, I made very good friends, and I was able to participate in outstanding collaborations. Now, many young people participate in this and other collaborations within the society and are now shaping the future of ESPID. For all these reasons, this is a very special day and a special moment for me, and I'm really greatly honored and thankful for this award. Thank you. Now, I will dedicate this honorary talk to childhood tuberculosis and share with you the most recent advances in the diagnosis and treatment of this disease. And I selected this topic because, based on these advances, we can now be, maybe for the first time in many years, we can be optimistic that during the next several years we'll be able to control the huge morbidity and mortality associated with this disease in children and reach the NTB strategy goals. And in fact, it is now a very good time for childhood tuberculosis, perhaps better than ever before in the past, because now children are in the focus of the efforts for TB control, whereas in the many previous years, the focus was on adults because they are infectious and they can transmit the disease to others. My conflict of interest form, nothing to do with this presentation. This is the outline of the talk. I will shortly refer in the current epidemiology and to recent advances in diagnosis selectively, because there is a lot going on, but time is limited, and to advances in TB preventive treatment, as well as treatment of TB disease, including MDR disease. According to the most recent WHO estimates for year 2021, there were more than 10 million new TB cases globally. Children accounted for 11% of these cases, but they accounted for 13% of the deaths, with an estimated number of almost 210,000 deaths, which means more than 600 children losing their lives every day. And it's really important that 80% of these children are younger than 5 years, and almost all of them did not have access to treatment. There is a huge detection and treatment gap in childhood tuberculosis because, as you can see in this graph, about almost 40%, only 40%, even less than that, of the estimated cases in children and adolescents under 15 years of age are reported. And this percentage is 30% for the younger under 5 children, whereas 64% of the estimated cases in adults are reported. And there is also a huge prevention gap because in 2021, less than a third of the young under 5 years of age contacts of TB cases actually received TB preventive treatment. And the percentage in older ages, because there is a recent recommendation by WHO to provide preventive treatment to older contacts as well, this number is negligible. So going into the recent advances in TB diagnosis, we have new rapid molecular assays. We have a new Expert Ultra, which was endorsed by WHO in 2022 based on the results of Cochrane systematic review. The test has a bit higher sensitivity and lower specificity compared to the old Expert because it has 5 semi-quantitative categories, and including the trace category, which trace calls are considered positive in people with postbacillary disease like children. and the test was recommended for use in all these types of specimens. There is a new ESPID to detect resistance for use in the field, ESPID XDR. It detects resistance to isoniazid, fluoroquinolones, ethionamide, and second-line injectables. It aims to be used if there is MDR or rifampicin-resistant disease, or one practices in areas with high isoniazid resistance. Now, of the other molecular tests, they are in use for several years in well-organized, well-equipped labs. I will not go through these details, but just put a star on the next-generation sequencing assays. Next-generation NGS assays are already in use in organized labs. However, there are new methods under development, targeted NGS assays, which use arrays of resistance genes, and they can be used directly on clinical samples, and the aim is to be used in the field. The technology is advancing. There are already portable devices, but the road to application in the field is still long. Now, it is true that in order to increase the diagnostic yield of childhood tuberculosis, there is a need to collect less invasive samples, child-friendly samples that can easily be obtained from young children in peripheral settings in low-resource areas where TB is endemic. And for this reason, and based on the recent Cochrane review, WHO recently endorsed the use of stool samples to be examined with the molecular assays. And although the yield of these samples is lower, have a little bit lower sensitivity compared to more invasive respiratory samples, however, the specimen is easily obtainable and can be used in any setting. There are also simplified protocols that can be used with the ESPID platform, like this one, the SOS protocol developed by KNCV recently. The problem is to detect resistance. However, as we said earlier, there are already NGS methods that are under development that can be used in the field also for stool examination. With regard to other pathogen-based assays, I will just refer to lipoarabinoma non-lateral flow assays. These were the first point-of-care test to be used in practice. The ALIR-LAM test was the first one. The test has low sensitivity, but when it is used in special groups of HIV-positive patients, it is associated, it has an impact on mortality. So that's why it is recommended. However, research is advancing, and there are next-generation tests, the FUJI-LAM, with higher sensitivity in children as well, as shown by studies conducted in children. However, the test was found in recent studies to have high lot of variability, so it cannot be used in its current form for the time being. There are novel third-generation ultrasensitive LAM tests under development, and they may be used in the future also for self-testing. So things progress rapidly. With regard to other pathogen assays, there are many of them. I will just mention this study, which I thought is interesting to share with you. The investigators looked for cell-free DNA in the serum, not with PCR like previous studies, but with the use of a CRISPR assay. And the results were very good, high sensitivity and specificity, both in adults and children, and also in HIV-positive children. However, the study was small with small numbers. It is very promising, though. It can probably be used to follow response to treatment. And now, on another tone, a number of investigators have looked into the host response, and specifically to the transcriptomic profiles of patients, in order to identify and discover new TB biomarkers, transcriptomic biomarkers, based on which they can develop new non-sputum-based point-of-care tests. Gene expression analysis has been used at different points in this cascade from TB infection to TB disease in order to develop diagnostic and prognostic TB biomarkers. So several groups have discovered diagnostic RNA signatures for the diagnosis of TB disease, but also or to be used as a triage test, both for TB disease and also for subclinical disease. And this is very important because adolescents and adults often have subclinical disease without symptoms, but they spread the infection to many others by the time they are diagnosed. So there's a clear need for better tests also for subclinical disease. Others have discovered signatures that can predict the progression from TB infection to TB disease, and there have been several studies in adolescents as well, and this can help to use TB preventive treatment more selectively. And finally, there are signatures that can monitor a response to treatment. Now, the WHO has defined target product profiles for any new diagnostic test, including these transcriptomic tests, and the lower cutoffs for the different uses are shown here. Now, several studies have been conducted in children which have examined the transcriptomic profiles, but only 2 published studies have discovered RNA signatures in children which can discriminate between active TB and TB disease and other diseases like pneumonia. This is a landmark study, and these 2 studies only used hypothesis-free transcriptome-wide analysis. And this is a landmark study published a few years ago. It was conducted in Africa and was led by Mike Levine's group at Imperial. And the investigators discovered a 51-gene signature which performs very well to discriminate between TB and other diseases. And in fact, the sensitivity was much higher than any other available test, including the ESPID test. However, the signature is large to be used for the development of a point-of-care test. So the same group recently discovered a reduced 6-gene transcriptomic signature for the diagnosis of childhood TB. The study again was conducted in Africa. A large number of groups participated, and the signature performs very well and meets the criteria to be used as a TB diagnostic test. You can follow this presentation by Hortensia Vito tomorrow morning on a session on diagnostics. And it is the aim of the Diamonds Project to use a small signature of differentially expressed genes to develop a point-of-care test for the diagnosis of TB, but what is more, with the use of personalized molecular signature diagnosis to differentiate between viral, bacterial infection, and TB in a child who presents with fever in a high endemicity setting. And there are several platforms which can accommodate the signatures in the available. The most well-known one is the RT-PCR platform, such as a film array by BioFire or the GeneExpert. The nanostring technology can also be used, and lately, a lab-on-chip device has been developed, which has pocket size and uses pH sensing semiconductor technology and can accommodate a small signature of up to 6 to 8 genes. This is a study, non-published yet, that was conducted in our center with a collaboration with a group from Imperial. We used peripheral blood mononuclears from patients with TB and patients with pneumonia, community-acquired pneumonia. The cells were stimulated in vitro with TB-specific antigens, or PPD, and one gene signature was discovered in this second group, which had excellent performance, and a 3-gene signature in the PPD-stimulated group. However, this is a complicated procedure to collect PBMCs and stimulate them, so there's a need to be, for the method to be simplified in order to be used for a point-of-care test. And finally, this is a very interesting study published last year. The investigators used a 3-gene signature discovered previously, and they applied it on the GeneExpert platform, and the test is called ESPID MTB Host Response. And they took blood by fingerstick from patients in Africa and Vietnam, adults, and they showed that this 3-gene signature has very good performance and meets the criteria of WHO to be used as a triage test. So it seems that we're not far from using new transcriptomic TB biomarkers for the development of non-sputum-based TB diagnostic point-of-care tests. However, For the time being, the diagnosis of TB in children and the decision to start treatment largely, in most cases, relies on clinical judgment. That's why it is a very big step forward, the endorsement by WHO of clinical decision guidelines, which are to be used, aim to be used in peripheral healthcare settings where inexperienced physicians examine kids with possible tuberculosis, in settings where resources are low and TB is endemic. So the aim is to facilitate access to treatment for these children and save lives. The guidelines were developed based on a large database of about 5,000 patients from 13 published studies, and you can see this, the publication, it describes the methods. Mathematical modeling was used to develop a scoring system, and they are valid until next year. They need to be validated. This is the way they look, the clinical algorithms look. There is one with a chest X-ray and without chest X-ray, and they are published in the operational handbook. The sensitivity is high, 86%. However, specificity is low because then we need to treat as many children as possible. However, specificity can improve in the future with the incorporation of computer-assisted interpretation of chest X-ray with the support of artificial intelligence, or with the use of biomarkers like the transcriptomic biomarkers we mentioned earlier. Now, going into recent advances in TB treatment, we have shorter regimens for TB preventive therapy. There is no need to use anymore the longer 6 and 9 month treatments with isoniazid. There is a preference over short rifamycin-based regimens because they are safer and because compliance is much better. The 3-month isoniazid and rifampicin is still recommended for young children because there is a fixed dose combination available. However, in the future, the rifampicin-based regimens will be preferred when there is more data about safety, about dosing in young children, and when there is a rifampicin formulation, dispersive formulation available. These include 3 months weekly isoniazid and rifampicin, or 1 month daily isoniazid and rifampicin. This is a study published by our center many years ago, where we compared the longer 9-month treatment with isoniazid with shorter 3 and 4-month combinations. It was clearly shown that compliance is much better with the shorter regimens, and we use ever since with great success the 3-month isoniazid and rifampicin treatment for TB prevention. Now, there is a change in policy endorsed by WHO recently. WHO recommends the use of TB preventive treatment also from children exposed to MDR-TB. And levofloxacin is recommended for 6 months with or without ethambutol or ethionamide. And the recommendation was based on a systematic review and meta-analysis, but there were observational studies, and there are ongoing now randomized control trials which will give more definite answers. We have new shorter regimens for the treatment of childhood tuberculosis, 2 regimens for pulmonary TB and 1 for TB meningitis. The WHO now recommends the use of a shorter 4-month regimen for children who have non-severe TB and are smear negative. The regimen has 2 months shorter continuation treatment compared to the traditional regimen. And the recommendation was based on this landmark study, the SHINE trial, published last year in the New England Journal of Medicine, which compared the 2 regimens and showed that the non-inferiority of the shorter regimens by all types of analysis. There is also a 4th-month regimen recommended for adolescents by WHO, adolescents with pulmonary TB of any severity and regardless of HIV status and regardless of the presence of cavitation. The regimen includes 4 months of rifampicin, isoniazid rifampicin moxifloxacin, and the pyrazinamide is given the first 2 months. The recommendation, again, was based in a randomized open-label non-inferiority clinical trial, Study 31. which proved the non-inferiority of this shorter regimen, again compared to the traditional 6-month one. And finally, a 6-month regimen is now recommended for TB meningitis, 6 months with daily administration of all these 4 drugs, with higher dose of isoniazid and specifically higher dose of rifampicin versus the classical 12-month treatment. And the recommendation was based on a systematic review and meta-analysis conducted for WHO, but again, the included studies were observational studies and showed lower morbidity, mortality, higher success of treatment, and more neurological sequelae, but the patients survived to observe the neurological sequelae. And there is now an ongoing randomized controlled trial with shorter treatment for TB meningitis with the use of levofloxacin and higher dose rifampicin that will give more definite answers. And finally, advances in the treatment of MDR-TB. Now we have available, safe, effective, all-oral shorter regimens for the treatment of this disease. No place for injectables. We have new, safe, and effective drugs, bedaquiline and delamanid, which can be used in children of young age. Bedaquiline can be used for longer than 6 months. If there is resistance to fluoroquinolones, we can use the combination of these 2 drugs. The duration of treatment is shorter. And finally, we have new child-friendly formulations available through Global Drug Facility. You can find any information about if you have a complicated patient like this in the guidelines and the operational handbook, and also in this field guide, which is dedicated to MDR disease. So in conclusion, there are several recent advances in the diagnosis of treatment and treatment of TB. We have new rapid molecular tests, several new pathogen-based tests under development. The use of non-invasive, non-respiratory specimens is encouraged. We have a new point-of-care test based on transcriptomics under development. A big step forward is the availability of treatment decision clinical algorithms. New shorter regimens are recommended for TB prevention and treatment. And a milestone is the development of evidence-based consolidated guidelines and an operational handbook by WHO. But in order to be able to use these new tools, there is a great need to organize decentralized services in the communities where TB is endemic, and this can be achieved through the use of already existing family-centered service delivery platforms that are used for the provision of child or maternal care. They can be used for TB services as well. And there is also a great need for continuous funding and resources and investment in implementation, as well as investment in the ongoing research. So we need to do all this and be successful in order to be able to reduce the deaths and the suffering for the children and their families, and reach the NTB strategy goals, and put an end to this old and very neglected disease. Thank you. Just one word. I want to thank my colleagues at our infectious disease units, the faculty and the fellows, the research nurses and the people in the lab, also my colleagues in the PTBNet and the Perform and Diamonds consortia, and finally my family, my husband and my children for their understanding and their support through all these years. Thank you very much. Thank you very much.